Here is my video, Antiderivatives Part 2. Alright, so I did Part 1 already. If you hadn't seen it, I think you should look at that one first. But the first video is what I would say the easiest problems and an introduction to all the rules that we'll use. And now this one has more moderate problems. Not the easy ones, but not the real difficult ones either. Anyway, so let's start with this one. How do you find the antiderivative of x times x squared minus 1 over 2x? Well, so I guess like it all comes down to needing to be like this, right? X to some constant power dx. And in addition to that, maybe we'll have something like a constant times a function, or one function plus or minus another. But it's got to be some combination of those three things for us to do it at this point, all right? So here's what I'll do with this one. First of all, I see that this is division, all right? It's not just addition or subtraction or multiplication by a constant. So I'll just try to reduce it down to the point where it's like the other problems that I showed you in the first video. Like, so for example, like first thing I could do is I got x over x. So those cancel like right off the bat. I don't have to do anything else with it, you know, at least initially. So I'll do that and I'll say, well, you'll get x squared minus 1 divided by 2, right, if you cancel the x's. Now, what about that, though? Remember, I need it to be x to some constant power plus or minus other functions that are of the same basic form. And with this one, that's a fraction, right? It's one thing divided by another. So I'll look at it like this. I know enough algebra that I can reduce this, right? I know that this is the same thing as x squared over 2, right? Okay, minus 1 over 2. And can we agree with that? Or why do I think that's true? Well, because you can subtract fractions with a common denominator, like these have. And if you did that, you'd get x squared minus 1 all divided by 2. So I know I can go from here to there. So therefore, I know I can go the other way and get from this step to that step. Now, one more thing that I'll do before I work this. This is x squared over 2. But really, I mean, I'm still trying to see it like my problems were in the first video. This is like this one. It's a constant times some function of x, right? Because to divide by 2, that would be the same thing as multiplying by a half. So I'm going to get 1/2 times x squared. All right, I'm going to see it like that. And then minus this constant of a half dx. Okay, so if I work from this point, where this is the point where I wanted to get since the beginning, all my rules accommodate this problem, okay? Then first of all, that constant, it will just be carried like so. This x squared, its antiderivative is x to the third power over 3. Okay, I carry the minus. What's the antiderivative of the constant 1/2? It's going to be 1/2 x. And then I get plus c like I always do. Anything else? Well, I'll clean this up a little bit. I got 1/2 times x to the third power over 3. That's going to be over 6. So we'll say x to the third power over 6. Okay, minus, I don't know, we could leave it 1/2 x. It's a little bit more condensed if I do that. So I'll say x over 2 and then plus c. Okay, and then we've got it. All right, now what about the next one? What does it have in common with the last one? Well, I don't have a rule for quotients yet. I have a rule for plus and minus. I have a rule for multiplying by a constant. I don't have a rule for a quotient. I don't have a rule for a product. So like this right here, x times root x, like I'm going to have to condense that into one thing. I don't have any rules for products and quotients, right? In case you're inclined, it's not true that the antiderivative of one thing divided by another is done in terms of the parts. You can't say it's the antiderivative of the thing on the top over the antiderivative of whatever's on the bottom. Like, that's no good. That's why I need to transform this so that it's similar to some other problem that I showed you already. Same thing with products, like the antiderivative of one function times another function is not the antiderivative of the first function times the antiderivative of the second one. It's not that simple. It doesn't work that way. So my point then is that I need to make that so it's not a product, okay? And that should be easy for us to do. Let's see, like, what's root x? Any other way to think about that? That's x to the 1/2 power. And from there, do the rules of algebra give us anything that to do with multiplying like things? Like, when you multiply like things, you add the powers. So x to the 1st power times x to the 1/2 power will be x to the 3/2 power. Okay. All right. So let's do this. Let's take this one kind of down here. So I'll get it's the antiderivative of 2x, and multiplying these together will give me the power 3/2. All right. Minus the constant 3k. It says k is a constant. Okay, so 3k is a constant. That's how I look at that. All right, now here I've got it in a way that I can work it. With this 2, I carry. With this, I will add 1 to that power, and I'll get 5/2. And I'll divide by 5/2. So I'll get like this, right? 2 times antiderivative x 3/2 power. Looking at like this. All right. And then 3k is a constant. Its antiderivative with respect to x is 3 times k times x. All right, then plus c. All right, so it seems like we have it, right? At least I did all my math as far as the rules are concerned. What's this thing right here? 2 and 5/2, though. We don't want to leave our numbers like that. So let's look at it this way. We'll say I have a 2, which I'll go ahead and write as 2/1. I'm dividing by 5/2, but that amounts to multiplying by 2/5. And then I got x to the 5/2 power. Okay, so then that's how the numbers work out right there. And then the rest of this, 3kx plus c, nothing I can do with that at this point. But this first part is 4/5. So I get 4/5 x 5/2 power minus 3kx plus c. All right. And there we go. Okay, so quotients and products, we're going to have to condense somehow, or combine or reduce, so that we get something that we already know how to do, like this or that, right? I took the quotient, made it into this, then I worked it. I took that product, turned it into this, and then I worked it, all right? Okay, so let's see. Next item is this thing that I call an initial value problem, and it deals with the, I guess you could say, to put it in informal terms, it deals with the constant of integration, okay? Meaning that, like, here's the first problem I did in my first video. I said, what's the antiderivative of cosine? What do you think it is? It's sine, right? Because the derivative of sine is cosine. Okay. But it could be sine plus any number. It's not like it's just sine, because the derivative of sine plus 5 or sine minus 2 is all the same. It's all cosine. So we have to say that there is this constant that gets added to every answer. And we can't say what it is unless we have more information. But say in this problem, I can't tell you what C is. I just know that it's there. In this one, I can't tell you what C is. I just know that it has to be there. Okay, now if you give me enough information, I can figure it out. All right, so here's what this one's about. It says, okay, I know the derivative of a function is 3 root x minus 1 over x squared. And I know that if I put 1 in for x, I'll get 4 out for y. So there's this function that I'm looking for, and I know two things about it. I know that this is its derivative, and I know that if you take this function, and if you put 1 in for x, you get 4 out for y. All right, what is the function? Okay, so let's do two things then. First of all, if this is the derivative of that, then I could find the antiderivative of this to get that over there. Let's make that the first thing that we do. So 1, this function f of x that we're trying to find has to be the antiderivative of that, right? So that's going to be 3x to the 1/2 power minus x to the minus 2. Right? I wrote that in a way that my rules apply to it, like I always would. It's just this thing. But if you take the derivative of this, you get that. That's what this says. So the antiderivative of this is equal to that. Okay, so that's where we would naturally begin with this. But what is that? What's the antiderivative of this? So it's 3, okay, which is that constant coefficient right there. Carry that over. And then I get, so I add 1 to this power, so I get 3 over 2. And then I'll divide 3 over 2. Okay, so I get like so with the first term. And I carry this subtraction, all right? And I'll get x to, so I add 1 to this, right? So minus 1 and minus 1. That's our rule. Okay, and then plus c. All right, so let's work this out then. So this is 3 times 2/3. So that would be 2. It's 2x to the 3 over 2 power plus 1 over x plus c. All right, so there's, I guess you could say, a partial answer to that. What is this function? Well, here, it's 2x to the 3 over 2 power plus 1 over x plus c. It's not the full answer, and I'll explain why, but all right, this is a partial answer. The issue is, what's the c, though? You know, if this was going to be the answer, then I would be able to tell you what this number was supposed to be. So far, it's just some constant that I can't specify. But sure, if I take the derivative of this, I'll get that. Like, that's what I have so far. But look, if I also know that putting 1 in for x will give you 4 out for y, then that's enough information to find that constant. Okay? All right. So let's make that our second step then. So second step says, let's just put it like this. If x is 1, then y is 4. So this function has to do that. All right? So let's do that. So if you put 1 in for x, you get 4 for y. So that will look like this. 4 equals 2 times 1 through to a power plus 1 over 1 plus c. This is me putting 1 in for x and getting 4 out for y. And of course, like that's like this constant is the only thing that's unknown in this equation. So we can figure it out. And here's how. So 4, 1 to the 3 over 2 power turns out to be 1. So this is 2, this is 1, and this is some unknown number at this point. It says 4 equals 3 plus what? C is equal to 1. All right, you solve for it, it's 1. So there's our full answer. Our final answer is f of x is 2x to the 3 over 2 power plus 1 over x plus 1. This function is such that if I take the derivative of it, I will get this. And if I put 1 in for x, I'll get 4 out for y. So it does that too. All right. So it's with that last piece of information that I can tell you what that constant is. Right? In every single problem, we've done. There's a plus c. And it's not until we get here where I give you that extra bit of information that you can actually figure out what it's supposed to be. All right. Okay. So let's take, I wanted to take another one like this, similar but different. Okay. So let's make it this one. Solve the initial value problem. I know the second derivative is 4 plus 6x. I know that if you put 0 for x, you'll get 4 for y. And if you put 1 for x, you'll get 2 for y. All right. Actually, maybe I'll do this one in the next video. I think I'm running out of room on my camera. But all right, for now, this will be the first video, first problem in the next video.